those coordinates. And the game is played by you start tapping on those blocks, and then if the square has a ball concealed in that, then the player loses the game. This is what the hardware we used. The SGEMA implements a high-speed data, which is transferred between two components, and then the FIFO is used to provide buffering, and the flow control for data transfer between DNA, read and write blocks, and LCD pixel FIFO is used for buffer data and to provide flow control in the SOPC filter. And the pixel converter, it receives the pixel data and transforms the data to the format required by the solution. Rashmi is going to explain this.
I am Rashmi. The basic idea of the game was taken from Minesweeper, but we couldn't implement the exact game. So we just implemented a simpler version of that. It's just guessing where you have the bombs and where you don't. It's just a gameplay. And where the mines are placed, then the game is just over. So this is the simple diagram. So we started it off very late, so we got very early not half this, the 3/4 done. This is how the flow chart works. So this is the hardware implementation. She's done the hardware implementation, and the software, the coding I tried to do. So that's how it is. So this is just a display of how the game looks like, and then there are hidden mines inside. So it's a kind of guess of how you start playing Minesweeper. So it's just that we just have this on the display. So it just takes, and
Unless and until you touch on a ball.
so that was a mine. So unless and until you reach a mine, you can continue to play. Once you are cleared, when you don't hit a mine, that's when you win the game. So that's how it is taken.
Project. My team members are Kabir and Venkatesh. We are here to present our project, so-called implementation of part10 game on keypad. So the main idea behind our project is to build a video game which is similar to the arcade game called part10 on keypad by using D2 threshold. It is also got another name. It's called breakout game. As you can see from the screenshots, these screenshots are of our game. There is a ball, there is a paddle, and there are bricks which are arranged in rows. So the paddle is used to bounce the ball. So as the ball moves and hits the bricks will disappear, and then it will break through all of the rows. So in this slide, I'm going to talk about how exactly the game is going to work. So at the start of the game, the player will launch a ball from the platform, which is also called the paddle. So as the ball keeps moving and then if it touches the brick will disappear. And the main role of the player is to move the paddle left or right, which will be at the bottom of the screen. And then it also makes sure that to deflect the ball to the upwards whenever it returns to the bottom. And the game ends when the player misses the ball or all the blocks on the screen are eliminated. And the next is the top level, which will be explained by Kabir.
Actually, the top level, we used, first of all, we used the PLL to generate the required clocking for the SPRM. We have 100 megahertz with the -65 phase shift. And for the VGA, we have 40 megahertz. And also the rest has 100 megahertz clocking. Actually, the pixel, all the modules have been interfaced by the main bus, and we have also the pixel buffer and the character buffer to send the picture and the characters to display and mix them before before the fight with the blind. Actually, our hardware have been implemented all in SOPC and where we use the CPU at the fast speed. The next slide will be about software part.
Hi everyone. This is the basic algorithm for our C code. First, we would like to start the game with the button called start, and the game doesn't start until the touch input is given. We have assigned select two buttons, that is for the start. And once it starts, it checks for the initial ball condition, that is for set for these coordinates. If it satisfies that condition, then it moves further and enters the infinite while loop. We have to put this while loop because the ball movement is continuous, so it has to be an infinite loop. And after the ball movement, it also we have also included three if conditions for the buttons. That is selection 0 is equal for moving left is assigned to the paddle movement, and the move right is assigned for selection is equal to 1 to move the paddle right, and the other is the select 3, that is the reset, which sets the paddle and the ball to the basic starting conditions. And once we have set one more condition where if the ball crosses or is equal to this coordinate, then it should be listed that game is over. Otherwise, it should reset and then start the game all over. So the basic HL function that we're using are the touch and the display function, that is the print data and the display, clear screen when the game is over, and video display register buffer for removing the ball trails whenever the ball is moving. So this is a software design, and we have divided our task in the following format. I and continue with the software and continue with the hardware. I've done the pattern and the ball movement, and continue has done the map and the touch interface. Let's move to the demonstration. So this is the overall display. These are the bricks, this is the paddle, and this is the ball. We have the 4 menu buttons. One is the left, start, reset, and then right. So when we push start button, the game begins and the ball starts moving, and simultaneously we also got the paddle and ball to move parallelly. And if it hits the boundary conditions, and it has to bounce back, and then if it hits the bricks should disappear. And the main thing is, if it touches the paddle should be able to bounce the ball back. So that is the purpose of the game, to save the ball going underneath it. So now we'll see what happens if the ball misses the paddle. So when the ball misses the paddle and goes under this condition, the game is over. So this will be the game for